I will be talking about advanced scheduling in Kubernetes. So let's go. I've been told to say a few words about an initiative that I'm volunteering it. It's OpSchool. This is the sticker. OpSchool is an initiative founded by the one and only Yaron Amir from Outbrain. In order to help individuals to elaborate their career to the DevOps world, and also to have like another DevOps community that we as companies can recruit from people. This is a volunteering only initiative. I'm volunteering in the coding session there, so you can go to opschool.org and register if you would like, if you're a developer or a sysadmin that you want to take your career to the next level. So feel free to register and we will contact you in the next semester. Last week we started the winter semester. So my name is Tsahi Duek. I'm a solutions architect from Spottings, infrastructure engineer, production engineer with a lot of experience in the productions world. So we're going to talk about scheduling in Kubernetes. What happened before that? Why do we even care? Because a lot of people tend to think that Kubernetes is high available embedded, which is basically not. I will cover the Kubernetes scheduling techniques that I'm familiar with and I want to share with you. I have a live demo, so you can see it yourself, and the resources I use to learn from my experience and to make this presentation. So a few words about myself. I'm married with children, not like this role model, but happily married with children. I like to drum, I like to play snooker, and 2 years ago I've just got my skipper license. On the professional side, I'm programming from the age of 6 or 7. This is me programming BASIC, not really, but BASIC was the first language I was being taught. Got myself to the mainframe world, COBOL, someone talked about it 2 sessions ago, and then I've started my journey around the DevOps. I didn't know what is this buzzword all about, but I found it very interesting. I started reading, started going to conferences. I even got to IBM, writing a book about DevOps in the mainframe, and then Docker, containers, all the life cycles of how we pack application, how we deploy it, how we utilize many of the instances that we already have with using containers. And of course, the end game is Kubernetes. And since then, I'm fully into Kubernetes, learning all the time and try to improve myself in this field. A few words about Spottings. Spottings basically manage tens of thousands of Kubernetes worker nodes on behalf of our customers. And we do it with an autoscaler we developed to keep the cluster tight in resources of CPU and memory. So, let's go back to the pre-Kubernetes architecture. We basically knew our infrastructure. We knew the location of all the instances. We knew which availability zones they have. We knew the instances by names, or at least by tags. And when we were deploying stuff, we knew exactly the process that we need to do in order to keep our application highly available, make sure that we have enough replicas across different zones, and basically this gives us the highly available architecture of application. And then Kubernetes came around and people just start deploying deployments everywhere, start just vector applying. And as I said, they tend to think that when I just asking Kubernetes for 3 replicas of code, I have highly available service, which is basically not, because as you can see, like on the blue pod here, you can see that they cannot tolerate a failure of a single instance. On the orange pods, they cannot tolerate a failure of a single AZ, which is not cool. So I will cover the next slide about how Kubernetes techniques used to address these issues. So the first one will be, what if I want to address a specific node? For example, I want to, my application need the 10 gigs of network bandwidth, and this comes only with the R8 large instances. And I want my application to run only on that specific node, on nodes that have this specific attribute. So this is kind of easy, and I'm guessing a lot of people that new to Kubernetes are learning this very quickly. This is basically, we get to this using a node selector. A node selector gives the scheduler information about which label and which value to look up a node and then schedule this pod on that specific node. This is a built-in label that Kubernetes label all the instances by default. You don't need to take care of it. So this is, for example, how I schedule my pod on the R5 large instance. But what if I run multiple instances and I want to address all the 8XL and all the 9XL instances? So I cannot target a specific type of instances. So in that case, this is a more complex example, but we have the affinity spec, and the affinity spec, we have the node affinity. The node affinity gives us the ability to use like an operation and multiple values on a specific label. So we use the same label as before, which is the instance type, but this time we give it a list of candidate values. And what Kubernetes will do, it will look up and all the cluster, and the first one it will find, it will schedule the pod on that specific instance. Actually, it's a kube scheduler task, but so the next thing will be application goes together. Per Kubernetes, we know how to package the two applications, deploy it on the same instance, and it was cool. But in Kubernetes, we need to make sure that this application will run together on the same topology that we would like. For example, if we're running application, different pods that need the shared file system on the specific instance, or we want to make sure that every component of the system will be highly available, and we need to have enough replicas, the same amount of replicas in specific AZ, and we want to allocate and we want to redirect them to that AZ specifically. Or we want to have a bunch of pods running on the same instance because we don't want the network latency between other instances. To me, it's like these two guys, Matt Damon and Ben Affleck, they've always been together. If you find one, you should look the other. You probably find them very quickly. And in Kubernetes, look something like that. We have a pod A and we have a pod B, and we want them, I don't care in which instance they will be, I just need them to be together. Or I do care, but I want them to be together on that specific instance. So this time, again, the affinity spec, and the affinity spec, I will use this time the pod affinity, which is similar to the node affinity. It gives me the option to use, a label on the pod itself, not on the node, because we have a pod affinity, and the list of value, and again, an operator. But the thing is to take into consideration is the topology key. The topology key is the domain or the address space, if I can think of it like this. This must be a label on all the nodes that I must that exist, and I must schedule my pod according to this label specifically. So in this example, I want my pod to be together, all the services in type of core to run on the same instance, and this is because my topology key is set to hostname. If I would like to run them for them to be run on the same zone, for example, I will need to replace the topology key with a label that reflects the zone on all the nodes. And again, this is a built-in Kubernetes node label that the Kubernetes is responsible for populating it. The next example will be, so okay, we have this pod A and pod B, but we don't want other pods to be on that instance. For example, we have a ephemeral instance store in the C5D, for example, and these two pods use that, but I don't want other pods to utilize this instance, this expensive instance store. And it's like a family meeting that you don't invite to, you didn't get invited to. Bad thing can happen if you break into one of these meetings. And this time, again, the affinity rule, but this time we use the pod Anti Affinity. The pod Anti Affinity tells the kube scheduler which pods not to allocate along with my specific pod. In this example, I'm using twice, one the pod affinity and one the pod Anti Affinity, and I make sure that only services with the value of core will be run together, and again on the same host, the topology key. Final scheduling example will be the multiple replicas instances zone. What if I want to spread my application across many instances, but I want them to be spread across zone? It's like cat in a hat. If some of you read the book, it has a lot of small cats that need to clean out the mess he did. And in Kubernetes, it should look something like that. I want at least 3 pods, but I want them to be available and multiple zone. So this time I will use the pod Anti Affinity, but I will use it twice. I will use it one in the topology key of hostname. Sorry. This is the hostname. And the second pod Anti Affinity rule will be, again, the same service, the same value, but this time it will be on the topology key of zone. This will make sure that my application will be spread out across multiple instances and multiple zones. One thing I want you to pay attention to, this is 2 important parameters that you should take into consideration. The required during scheduling and preferred during scheduling. Required means the kube scheduler, you must apply this Anti-Affinity rule at any cost. If there's any pod available to sustain this Anti-Affinity rule, the pod will stay pending and will not be scheduled on any node. The preferred, as it said, it's you should try, but if you don't have a node, just target one and target on the specific node that you found. And the reason for that, and I encourage you to read about it, there's on the Kubernetes documentation side, they had a lot of details why using required with zone can have a deadlock effect on all the clusters. So this is something for you to take home. The other scheduling techniques will be the taints and toleration, but this time we're not telling the pods to be scheduled on a specific node. We tell the nodes which pods they must repeal. So taints are the attribute of the pod that said which, the attribute of the node that said which pod can be allocated on the specific node, and the toleration is a label on the pod that allow this pod to be run on the tainted node. Additional consideration: PVC location. PVC is a region, is a zonal entity. And you must take this into consideration when schedule your application. For example, like stateful set, and you need to know in which region, in which availability zone the PVC was created. GPU, taint them. We have a lot of customers like running GPU and they don't have taint, and then all of a sudden they ask why this pod use my expensive GPU instance. I don't want it to be allocated there, so taint your GPU node. And the last thing and the most important is the last sentence. Don't let coincidence. A lot of people ask me, like, I just run kubectl apply the deployment with 3 replicas, and all the pod was scheduled on different nodes. So I don't know what you're talking about, but this is a coincidence. This is not something that is happen like it happened just by coincidence. It is your responsibility, and you should take care of scheduling your application correctly. To me, it's like a set theorem. Anything you can express like in a set theorem can be expressed as a pod affinity, anti-affinity rules, and node selectors. And for the demo part, so I have 3 nodes cluster backed by our autoscaler. I just want to show you that this, for example, I have 3 instances on US West 2A, B, and C. This is the instance types. And the first thing I want to demonstrate is the node selector. So let's go for this type. Again, as I've shown earlier, I have the C5 9 extra large instance. I will just applying this, I think it's deployment, yes. Yeah. So at the moment, what happened is behind the scene, our autoscaler spotting autoscaler identify the request of a new pod. So if I watch the pods, you can see that this pod is currently pending. But on the infrastructure side, this is just for you to understand the concept. There is an instance that is being launched, C59 extra large, to have this type of instance for the specific pod. In a few minutes, it should be ready, and the pod will be in a running state. The next example, while this instance is launching, is again the node selector in node affinity, which is this one. Yeah. So again, I have a pod. I want to schedule it, but I don't care if it's R58XL, C59XL, M58XL. I just want it to be scheduled if there's a sufficient instance, if there's a appropriate instance with that specific value. So. Yeah, okay, so this now is running, and if I go with all the different nodes, you can see that I have a new node on the cluster with the C59XL instance type. So let's go back and apply the node selector in node affinity, which is, as I said, this is this deployment with the multiple values. And because I already have this instance ready, you can see that it is running immediately. Next example will be the pod affinity. I want 2 pods to be allocated on the same node. So I have a pod. Let me close this one. I have a pod affinity core A with a label service core, and I want it to be allocated with a pod affinity only with other pods that have service core in it. And the topology key will be the host name. Again, I have another pod B, with the same attribute and the same pod affinity and the same topology key. So let's see how it goes. Okay, great. So I have these 2 pods, and to demonstrate that they're running on the same instance, so as you can see, I've just target the specific service equal core, and these 2 pods run on the same node. Next example will be the pod anti-affinity. The pod anti-affinity will basically be a pod which is not core, and continue to the previous example. And I don't want it to be allocated on instances that have the service core in it. And why is it instances? Because again, because the topology key is host name. If I don't want to be on the same zone, I will press the label. I will replace the label with appropriate label that reflect the zone. So again, applying this example, and the pod is created, but this time, this was the pod that ran on the service with the service core, and this is the service which is not core, and you can see that these two was scheduled on that specific node, but the not core service was scheduled on a different node. If I'm switching fast, so please stop me. The next example will be deployment in in high availability method, but with topology key of host. So I have 3 replicas of this deployment, and I have a pod Anti Affinity with the same label of the specific deployment itself. So you can see that the app Anti Affinity host. This is the label that I have in the pod spec for that specific deployment. Let's deploy this application. Okay. And if I target all the pods with this specific label up Anti Affinity host, you can see that it was being scheduled on different nodes and not on the same node. And the last example to simulate the multi-AZ and the multi-host deployment, this is the most advanced example there is, I think, which is the pod Anti Affinity one time on the topology key of host, as you've seen on the slide, and the other time on the topology key of zone, but this time with preferred. I'm guessing I have enough room on those nodes to allocate those pods in terms of CPU memory requirements. Okay, that's great. And let's get all these pods. And as you can see, this was run on 3 different instances, 3 different nodes. Let's get the node zone just to match them to availability zone. So 214 was in US West 2B, this one. 137 is the US West 2C, and 187 is the US West 2A. And this is the final demo for this presentation. You can find all these examples on my GitHub. I've created it just to simulate how easy it is to perform this test. I even wrote a Medium blog about this subject. And all the ideas and all the things I've learned during this process was been taken from the Kubernetes docs website, and in the GitHub, in the Kubernetes community, they shared a lot of design proposals, which they have design proposals on everything, like in the controller, on the control plane, and you can just go there and read about anything you would like on Kubernetes. So they have like a node affinity, pod affinity, and this is where they explain why if you have pod affinity, pod anti-affinity with the card on the same zone, this can be a deadlock on your cluster. Thank you.